Alrighty, so I have an issue that's been happening the last few days, and I decided I'm going to fix it. But while doing so, I thought, well, we'll make a project video to show you guys. It might just help a little bit. So, for starters, we have a fridge, right? And that fridge is in my four-wheel drive. Now, that fridge is powered by the battery, more or less. So we also have a fuse. It's a bit more extravagant than this, but for the basic simple process, this is what we got. We have a negative. Negative wire runs to the fridge. We have a positive, makes its way to the fuse. The fuse is a 10 amp. My fridge draws 6 amps at max, so 10 amp is safe. So, that's our basic setup. Adding to this setup, I also have solar panel, and that's on my roof of my car. And it's always feeding, and it goes to a controller, which we'll just represent with the letter C. So from there we have the negative. The negative from the controller goes to here, to the battery. Positive from the solar, and the positive over that, it goes to the battery. So for the most part, it's consistently running 24/7 an hour, 24 hours a day, 7 days a week. System works great. I could upgrade the battery, and I will be doing so in the future, but for now, if I have overcast days, like really cloudy, which we've had for the last week, 2 weeks, we find my battery's starting to get low, and I don't like that. And given that the car's parked accessible to electricity every night, I'd like to plug the fridge into the electricity just to help it all out. Or if I'm at a campsite, I'd like to plug it in, whatever. So, it's a real pain to slide the fridge out, reach behind, unplug the plug from the back of the fridge, plug the power in, and all that. I'd like it all to be fully set up and it just automatically change over as soon as I plug the power in. So saying that, today's project is fixing that. So right here, we have a power adapter. This is a power adapter for my fridge. This is the plug for that adapter. I've already cut that off. So I need to cut that off. That's simple. Now, you'll normally have bare wires. I've already pre-worked a bit of this project. So right now, we have a cut. Well, you can see I've represented the red as the positive and the white as the negative. However, these cables are just black. So you really actually don't know which is which. So we can do a couple of things to fix that, starting with using our multimeter. So grabbing our multimeter, if we have one. If we don't, I'm going to show you how to work out which is positive and which is negative, which is really simple. Set your voltmeter to your volts, and 20 being that we're running with a 12 volt system here. Make sure your wires are not connected together. If they are, they'll short out and spark. Disclaimer, I hold no responsibility for any damages. But continuing on, plug your adapter in. You can see the green light's lit. Now, I'm going to hook these up wrong so that you can see the wrong way, as I already know which is which. So if we just went, okay, that wire and this wire, you get a reading of 14.6. Now, I know I said we're working with 12 volt, 14.6 is actually a fully charging, that's the maximum of the area that the voltage is running in your car. So we're at 14.6, but if you see we've got a negative sign next to it, that negative sign means that we have the polarity incorrect, so it's wrong. So if we just take these out, swap them over onto the other wires the other wire, now we'll get another 14.6 reading, but we won't have the negative there. This only works with cars. I'm not talking about electricity. Electricity is a completely different ball game, and I don't touch that. That's AC. We're playing with DC. So now that we know which is our positive and negative, we should mark our positive wire or our negative wire. If you've only got black tape, put a bit of black tape around your negative. Then you'll know that the black tape means negative. And we need to know this for fast forwarding through the project. So now that we've established this, I'll get this out of the way. And we get to start with the goodies. So, this is a fuse block with many fuses, multiple fuses. I'll take the cover off so you can see it. These are all 10 amps. Now, we only need one today, but I've got that. I'm just using parts to represent to show you how we're going to do this. So we've got that. Our fridge will be represented by this light. So there's our light. It has a positive and a negative. Now it's quite as simple as if we connect our red wire, our positive, to the fuse, keeping our earth away, and we take our positive from our power supply and connect out the other side. Now we just have our earths left. Now if I was to put our earths together, we have light. And we disconnect it and it goes away. On, off, on, off. Very simple. But to me anyway, I don't mean to make anyone feel belittled for not knowing that. That's what I want to teach. Anyway, I'm going to unplug this for now. Now, over here next to us, which you can hard to see, I have an actual car battery, 12-volt battery, which I can probably show you guys kind of, there it is there. That represents our 4-wheel drive battery. And so off this, I have a couple of clips. Right, whoop, I'll use my cover. We've got a couple of clips. These clips I need to use for this. Same deal. If we were to connect the negative to the negative, which is a little bit harder with these clamps, and I connected the positive to the positive, we get light. So my problem is now I have to keep changing the plugs or changing these wires around to change my power source in the car. And that brings us to relays. Now we have these things called relays, which I have a couple here, and I'll go grab the other one because apparently I've forgotten it. Okay, so we have relays. Right, relays come in multiple variations. Right, we have the 4-pin. 1, 2, 3, 4. We have 2 5-pins, but these are different. I'll go into why in a second because that means a lot for this project. A relay's job is quite simple. If you have a switch, nice little switch, toggle on off, right? And these switches are normally rated for about, I don't know, let's go say 1 to 2 amps, right? You got on, off. And so if we were to connect, let's just move this out of the way. If we were to connect our fridge and let's say we wanted to put a switch on our fridge, okay? So if we cut the wire here, fuse first, then switch. And we took the power and put it into the switch, and then the other side of the switch back to the fridge. If we ran this like this right now, we would destroy the switch. The switch would be no good because it's able to run 1 to 2 amps. Our fridge, however, runs up to 6 amps. So it may not be as catastrophic, but that switch will fail. How do we fix that? We take these 2 away again. And we put in a relay. Now with a relay, you will run, it has multiple cables. The 4 cable one is simple. You'll run an earth. You'll run this big positive to the relay. You'll run your fridge to the relay. You'll take this red here and you'll put that to your positive from the battery, not from the big wire for you, not from this side of the fuse. And then this wire will come back to the relay. And what happens is this becomes your trigger wire. This becomes your output. This is your in, and that's your ground. So your earth, your ground. And what this does is inside there's I don't exactly understand the right words, but it's a magnet that triggers a contact that pulls down and up. That means that there's no load on this switch. It doesn't get 1 amp, 2 amps. It's very negligible. All it is telling this relay to do the job. And these relays are made to switch. Well, I think this one's so that's a 40 amp, right? So 40 amps. So we could run 6 of them fridges off that, technically. We're not running switches. I don't run a switch, but we still run a relay for what we're doing today. So I'll just remove the switch. But that's the idea. An idea behind a relay, for the most part, is to take a source and trigger it like that. Now, rejoin our wire up. So what we're going to use, as you can see, that relay does that. That's a 4-pin. My apologies. A 5-pin, it has 2 outs. So but there's a special one. If it has written underneath 87 on, I need something to point out properly for you. This pin and this pin here, these two, if it has 87 written on the both of them, then they are just one pin. It's the same as the 4-pin, right? That's all it is. Them two will be the same. So we can't use them. However, on this one has 87A. 87A means it switches between these 2 contacts. So one will turn on or it will turn off. That works in our favor because now when the power is off, we want the battery to be doing the fridge. So this is an on and off, which means we can use this as a trigger. So if I draw this up large as the relay, this is my idea behind this, and I believe it's going to work. And we have that's 87 and that's 87A. Then this one down here is 30, I believe, yes. And then we have, yes, we have 86, sorry for my writing, and 85. Right. So what the idea is, we're going to take both of these feeds and feed them in so that when the power turns on, it will switch to 87, which disconnects the battery but connects this power through. And then when this is turned off, it will turn the relay off, which will return back to the 87, which is the battery feed in. Now we have to wire it a little bit backwards, but that's okay, because normally this is your in and these are your outs. So today we're going to make these our ins. So, power, battery. And then this one here becomes out. And out's going to go to our fridge. Battery coming in, well, it's going to go to battery, isn't it? So battery coming in goes to here. And then that leaves us with power to come into 87. All the earths and negatives can get connected up together. They're fine. They don't need switching fuses and none of that. We're only fusing our positives in this situation. So let's continue on down this rabbit hole. I'm hope everyone's following this, because I'm hoping I've done this in a really good way that you can understand. Feel free to ask any questions. Like, subscribe, follow, help me out. More I get likes, more times I can do this, and more I can give good content. I need feedback for it. So let's go with, we need all our earths connected, right? So I'm just going to twist these two together. This is very temporary for this test. If it works, then we will continue on and I will build the real version for the car, and then I will show you guys the after, so it all set up afterwards. So as you can see right now, I have the earth from my 12-volt battery, and I have the earth from my power coming in. This is going to get messy real quick. I'll try and keep it laid out a bit. For now, I'm going to disconnect that power from that. The light will turn off. It has a little bit of power stored in it. Now, if we've got everything correct, so I should be able to, right, we'll start wiring it up. Okay, so on our relay we have two pins. We have 86 and 85, they're our switching pins. So 85 is our positive. So that's the one we want to control the on-off in here, which is going to be our adapter. So if we plug that onto here, like so, then we take the negative, which is also, not that one, sorry, the negative which is here, and that will go into 86, okay? From there, we have the power feed. So the feed that's coming from the 240 up here to 87, we're going to put up on 87. So that leaves our output. So I'm going to remove the fuses from here. This is the risky part, but I know what I'm doing enough to do it. I'm not going to blow it. I'm not worried about blowing the light or anything, but you do need a fuse. But just for concept, that's hooked up. So right now, if I plug in the power, our light turns on. Yay, congratulations. We've done great. So remember, this is our trigger wire, 85. If I disconnect it, the light turns off. On, off, on, off. And if you listen, you can hear the click. Now, what we want to do is we need to hook the battery up to 87A. Now 87A is, one second, I'm just going to get it. I'm just going to use a little jumper here to get the wire out so I can put the clamp on. 87A is the middle one. Okay? 87A is right. So right now we're running off the battery. To give you the proof, here's the power. We disconnect. Okay? We're still running off the battery. If I disconnect the battery, which is all known as this one here, the light turns off. On, off, on, off. Now, if I connect the power up, now remember that, so that green light, you remember the green light means that you've still got power in the adapter. If I try and click it, it used the last little bit of power and turned it off, okay? So as you can see, now there's no click. The light is flat, like it's off, there's no power, it's disconnected. Now if I plug it back in, okay? And now if I change it over, did you see that little flicker in the light? That is the light changing between power sources. Now, to make sure that we aren't backfeeding or changing anything, we're going to take our voltmeter. Now, we will remember that the power from our adapter was 14. Where are we? Sorry, I'm just trying to, am I on the right pins? I am not. So if we take the negative, and we take the positive, we have 14.64 volts. If we take our battery reading, 12.3. It's actually going flat. No, 12.3 volts, right? So we have essentially, if I disconnect, see, so we're going to take it off. So now we're back to battery. So if I go back to battery, you should see that voltage drop, 12.12. So there you go. Now, if I wire this whole system into the car with that in mind, all I need to do is have the plug sitting at the back of the car, or make a spot to actually plug in a lead. And when I get home, I can disconnect the power. Well, actually, we'll leave it plugged in for a sec because I forgot to hook the trigger back up. So, rightio, we've got home. It's been all night. We've plugged it in. The fridge is run off 240 volt all night. Well, 12 volt, but off the power. We're all done. I got to go the next morning. We come to the back. We disconnect the power. The fridge just cycled over to 12 volt. And we're like, right, this sits in the back of the car until I need to come home. Now, we've just made an automatic swap, power switch system. I hope this helps someone out. I will continue to design this more with the plugs and all the stuff I need in the car, and then I will do a follow-up video, or I might add it to the end of this next. Well, you guys will see it in the next couple of seconds if I add it to this video. If not, it will be in an upcoming video showing it working. All right, thank you. Remember, like, subscribe, follow, check out my Twitch. We do live streams on Twitch. I do live streams on YouTube soon. Mostly Q&A, talk just anything. A bit of gameplay on the Twitch if I feel like it, but mostly it's Jed projects, teaching things like this. We've got projects everywhere ahead to get done. So, all right, thank you.